How are we going, everybody? Welcome to Isaac's Dev Corner. This is the first video in the networking series which I'm going to be doing. This series is going to be about computer networks, how IP addresses work, everything about the internet and how devices communicate over the internet, and the whole wide array of topics. This is a very big sort of branch in the IT space, and I've just finished doing that in university for one of my semesters, and I feel like I'm at a level where I can teach some of the information and try to do it in the best format I can to try and make sure it's digestible, because I feel like a lot of the way that people do lectures in the universities is they're not really attuned to the younger generation, so the way they teach isn't really the best. So I'm going to try and do that to the best of my ability so I can teach other people who want to learn the topic, and it also reinforces my knowledge. Okay, so basically the syllabus is going to be looking like something like this. We're going to cover all these different topics, as you can see. It should be on the screen, and we're going to run through them in each video and just try and break it down, and I'm going to also put it all in a playlist, so it'll be under like computer networks or something along that lines of networking. Okay, so if you go in the playlist section, there'll be that, and today we're going to be start off in an introductory video just to the basics of how the internet was birthed, what is it, and some basic networking terminologies and some OSI Model stuff that you guys can have a look at. We're going to get into the PowerPoint. I've made like a presentation we can go through, so it all makes sense then. But nonetheless, guys, I hope you guys will enjoy this video. Make sure to leave a subscribe and a like and a comment. Let me know what you guys want to see in the future. I'm going to be making a wide array of different coding videos and IT videos in this space, okay? So, hope you guys enjoy this video and stay tuned. Righty guys, welcome to the section where we start getting straight into the meat of this video, okay? So, the agenda of today's video is to go over the internet history, networking terms, basic network communications, and the basic network architecture, okay? So in this video, we should have a basic grasp on this. I'm not going to go into insane depth about any of these things, but rather just the basics on them, okay? So, first thing is internet history basics, okay? So 1960s, basically the US Department made a project called the ARPANET, which connected 4 major universities. 10 years later, the ARPANET expands, the first email is sent, the term internet is coined, short for interconnected networks, okay? 10 years later from then, the DNS, domain name system, is introduced to simplify website addresses, okay? So it's basically making sure we don't have to like type in IP addresses. So it's readable human names, basically, like domain names. Now, TCP/IP becomes a standard communication protocol in the 1980s. Now, in the 1990s, the World Wide Web, so WWW, is created by Tim Berners-Lee, making it easier to share information and launch websites. 2000s, this is like when the big internet boom was occurring. Around this period, the internet becomes a global phenomenon with widespread use of search engines, online commerce, and social media. 2010, which is decently recent, like only 14 years, not even decently recent, that was 14 years ago. It's very, very, very crazy. The rise of smartphones and the expansion of high-speed broadband led to increased internet access and cloud computing, okay? So I think that's pretty straightforward. That's a brief summary on that. You can look at so many different videos in that one, and it will go into much more depth about the history, okay? Internet history, NCP replaced by TCP/IP. So NCP is Network Control Protocol, which was an early networking protocol used in the ARPANET, one of the precursors to the modern internet. Now, the ARPANET used NCP as its primary protocol to establish connection between computers on the network. The limitations of this protocol were it was scalability and flexibility. And this is replacement by the TCP, which is the Transfer Control Protocol, and the Internet Protocol IP. Okay, transition to the TCP/IP. The transition from the NCP to the TCP/IP began in the late 70s, and by the 1983, the ARPANET officially switched to using TCP/IP, and it's a standard protocol now. It's the dominant protocol. It is used widespread amongst everything, pretty much, and it includes IP addresses. It became the foundation of the internet and remains the predominant networking protocol used today. Okay, so basically it got switched over, so the NCP got transitioned to the TCP/IP because it's just better in every way. That's all you need to know. But if you want to know more depth, you can look at that later. So we have networking terms. So we have the LAN, WAN, MANs, and internetworks. Okay, so I've done a little visualization here. I just took from Google, and we'll run over that in a second. But first, we'll look at the descriptions and what everything means. Okay, so a local area network / LAN is a network that interconnects devices within a limited geographic area, e.g., a university campus or office. Okay, so in our illustration here, A LAN is like just your local spaces. Maybe it's a system of networks, not a system of networks, but it's a network. Maybe it's your grandma has a printer, a computer, and she wants to merge all these different devices together in an iPad and make sure they can communicate with each other. That will be what we call a LAN network, okay? Wide area networks, WANs, use the services of third-party communications providers to carry network traffic from one location to another. I should have done man there, but it's okay. Well, as you can see, wide area networks is like the very big, so that's connecting like networks to a very large location. It's basically saying the size of the network, okay? So if it's LAN, it's a smaller, it's like contained within one space. Wide area is like big, and then MAN is metropolitan area networks. This is used to interconnect LANs in a specific geographic location, such as a city or a county. As you can see, we have like a city, and we're connecting them two together, and they all like tie in together to create the whole entire internet. When you have LANs, MANs, and WANs connected to each other, you've got LANs here connected to that, which makes a MAN, and then you have over here, which makes a WAN, and all these little they just make sort of like a brain, right? It starts with something small and it just spreads out and makes something big. But they all start from small networks and they all branch out. Let's go back, yeah. So, internetwork is a networked collection of LANs tied together by devices such as routers, okay? Now, we'll go into all that stuff later, but now let's go to this next one. So, the internet, intranet, and ethernet, okay? Internet is a global public network of interconnected computers and servers accessible to anyone with internet connectivity, okay? So the internet is like it's like everything. It encompasses everything, the information and the accessibility of pretty much everything. Now, I'll do the extranet first. The extranet, I should actually change that to that one. Did that wrong. Anyway, a network that extends beyond an organization's boundaries to allow authorized external parties such as partners or customers limited access to specific resources or collaboration and data sharing. Over here, you've got suppliers, customers, etc. So more so contained communication. Intranet is a private network within an organization restricted to internal users. So as you can see, maybe it's like an organization used for sharing internal communication and information, okay? So basically like the internet, but it's more gate-kept towards maybe a business or something. Maybe they have special security measures and so on and so forth. Packets. So a small unit of data transmitted over a network containing both the data being sent and the control information to ensure it reaches its destination correctly. Now, I don't remember all this stuff. Like I finished my course a few weeks ago, but it's the basic idea of what a packet is. It contains information, it contains header fields, it contains frames, it contains everything that is stored. So as you've got here, you've got source IP address destination, you've got packet length, you've got the checksum, you've got the time to live, which is a TTL, you've got the version, the length, identification, and all these different things, okay? Now, it's 4 bytes across and 32 bits across in information and 24 bytes vertical, okay? Now, we'll go into that in a second, but that's what a packet looks like, essentially, in an IPv4 sort of communication system, okay? Now, bits. A bit is a binary digit, the smallest increment of data on a computer. A bit can hold only 1 or 2 values, 0 or 1, corresponding to the electrical values of the on or off, respectively. This is the binary system. We actually do go into this, these sort of like to the power of things, which is going to be used, and we have like a few rules to find out like devices, how many hosts can be on a network, and etc. But that's for a later video down in the lecture. But as you can see here, 0, 1, 0, 1, 0, 1, 0, 1. This is just how computers represent information, and it also corresponds with subnet mask and all these different things, which we'll be going into a second. But bits are just zeros and ones, and they respond to an electrical value, well, on or off. But that's represented in electrical impulses. Okay. Now, network communications. Computer networks consist of 2 or more computers connected by either cable or airwaves, e.g., Wi-Fi, stuff like that. For a computer to access the internet, it must be able to connect to a network. Now, as you can see here, these are like people who are connecting via cable or network or Wi-Fi, and that creates a network of information. Now, let's keep going. So the network communications, we've got the network interface card, which is the NIC, which is like the hardware. You've got the network medium, which is also, I believe, hardware, like cables and stuff like that. And you've got interconnecting devices, which is like routers, modems, all that stuff. We'll start with the NIC. So it's a hardware component that connects a computer or device to a network, enabling it to send and receive data over the network. NICs typically have a unique MAC address and can be wired, Ethernet, or wireless Wi-Fi. So this one, I have one of these on my desktop, so I don't have to have Ethernet. So it just connects in, sort of like it actually takes in the information, transmits, and does all that from this NIC. And then here in laptops, they generally made like this, where, or not even just laptops, but desktops too, where you can just plug it in and it will set up like that, okay? Now in phones, it's different, doesn't have this big thing like that. It's just, but the same base idea is the same. They use a NIC to then connect to a network and do the processing and information, all that stuff, okay? It just looks different in different ways, okay? So network communications, network medium. So there's Ethernet cables, which attach to the NIC of the computer network, the computer, for connecting to a wide network. So this is just an example. I don't know if this is a computer. This is probably like a router or something. But you know how when you have the computer with the Ethernet port, you plug it in. That is what the Ethernet cable is, and that's going into the NIC. You have the wireless NIC, translates data into radio signals and transmits the signals through an antenna for wireless connection. Okay, I think everyone can understand that. You got a router. So a router is the top one up there. A router is a network device that connects different networks, directing data packets between them and determining the best path of data transmission. Okay, and I'm assuming everyone of you has them in your house. It's very common. Routers are just very common. So the next one's a switch, a device that connects multiple devices within a local network LAN, forwarding data to specific device it's intended for based on MAC addresses. Okay, we'll go into MAC addresses later, but essentially they're basically for finding devices in a local setting, because once information gets there, it needs to know where and which device exactly is the data going to, and that's how you determine that through MAC addresses. We've got interconnecting device, we've got an access point, which is the top one on the right, a device that allows wireless devices to connect to a wide network, commonly used in Wi-Fi networks to provide wireless connection access. These are all just different devices for networks and routing and connecting things together. Next one, you've got a modem, a device that connects digital data from a computer into analog signals for transmission over telephone or cable lines and vice versa. It's like at my house, I have a modem that does that. It transmits from the coaxial cable, which is analog signals, I believe. I'm not too sure of that one. I have to do more research on that one. If I'm wrong, correct me. Anyway, this is what it looks like. You have the internet, you have the modem, you have the router, you have the device. And different networks can look different. Like you could just plug straight into, I'm pretty sure you can have situations where you just plug straight into the modem, Ethernet, and then there. I'm pretty sure. Anyway, peer-to-peer network. So peer-to-peer network, this is a peer-to-peer system. You've got a wide connection between two devices, and here's a wireless connection between devices. Communication steps. So generally what happens is, so the data source is sent from a device, and the NIC, right? So the device NIC packages the data into a frame with the source and destination MAC address. The switch, which is that hardware device, if local, the switch forwards the frame to the correct device. Router, if remote, a router directs the data to the targeted network. Internet, data can traverse multiple networks if necessary. Destination NIC, the NIC at the destination extracts the data. Data processing, the destination device processes the data. Response, if needed, a response following a similar path back to the source. Now that's basically the sort of like flow of how data is going to be sent in a more or less basic way. Okay? Here's what it kind of looks like. The sending machine will go through the used application, it goes to the software, goes to the network protocol, to the network interface, to the medium, which will be the cables and all that stuff, back through, back up. So think of it like a U-shaped relationship where it's going up and or down, across and up. And think of that's PC1, PC2 or something. Okay? And throughout that, you've got different networks, hardwares, and different devices which are used to get that information over to there. Like here you've got like software and you've got like applications and stuff. Now, the network architecture is the next one I want to talk about. The OSI is proposed by the International Organization for Standardization, ISO. OSI, I think I spelled that wrong. Provides a common framework for developers and students for networking to work with and learn from. It is not specific to any protocol suite and can be applied to most networking protocols. It is well known and acknowledged as a baseline for categorization of network communication functions and assessment. So basically, it's saying that this OSI model is universal. It's not an exact blueprint, but rather it encompasses pretty much all protocols in the sense that it's compartmentalized in sections so we can easily understand it. Does that make sense? So we've got layers which sort of have meaning, and then you can sort of like frame a logical idea on how it works. Okay. So we've got the OSI model and we've got the TCPI model. The TCP/IP model is more so a simplified version of the OSI model. And in university, we've been doing the OSI model. So with the OSI model, I would just recommend doing that one, like learning that. It kind of breaks it down in a more not understandable way, but in a more detailed way. If you want to get a more detailed explanation. But we'll quickly run through it. So you got the application layer, your presentation layer, your session layer, your transport layer, your network layer, your data link layer, and your physical layer. Okay, I'll go over exactly what they mean in a second. But as you can see in the TCP/IP, you've got application layer encompassing application, presentation, and session. And then over here, you've got the network access layer encompassing physical and data link. And that's one way to do it. I prefer this one because it's just the one I learnt with. But you can learn both and just try and understand what they mean. And we'll go over in a second each individual one and what it exactly means and everything. One way I do remember the OSI model is because I know it can be a bit tricky to remember all these different layers. Is as an acronym. It's PDNTSPA, which means please do not throw sausage pizza away. This is taught in university. It's a silly little acronym, but just try and remember it. But it's not like in reality you ever put in a situation where you have to remember where you don't have access to the internet and you can't Google it. But you know how university tests are when they like force you to remember things that, in reality you're not going to be tested on per se. Like no one's going to put a gun to your head and say, remember this exactly. Well, I guess it is good to know. That's why I have the acronym up there if you guys want to use that. And if you want to develop an acronym for this one, I'm assuming it'll be easier because there's only 4 layers. Okay. Now, here is a more in-depth. We're going to go into more in-depth on each one, but here's the basic understanding. So application layer is a human computer interactive layer where applications can access the network services. So that's different sort of services. I'm sure there's many you can think of right now. Comment them below if you can think of any. The presentation layer ensures that data is a usable format and is where data encryption occurs. So this layer is where the data encryption occurs and it makes sure it's in usable format. Session layer maintains connection and is responsible for controlling ports and sessions. Okay. Sessions, it means maintaining the connection between 2 devices, and then the ports is like the different types of ports that you use, and that will be actually in another video. Ports. Transport layer transmits data using transmission protocols, including TCP, UDP. Quick description on TCP and UDP. TCP is more for reliable connection. UDP is more making sure data is made sure it's sent. The one way I can look at it is TCP is for more when you want to make sure things are sent with guarantee, but UDP is more like for streaming, for gaming, where you can have packet loss and stuff like that, but it comes really fast. So there's different in the protocols, and I will be going over that more in depth in a different lecture. But for now, that's out of the scope of this first lecture. Okay. Number 3, you got the network layer, which decides the physical path the data will take. Okay, so this is where you will be giving your device the packet, your network, your logical address, and destination and source and all that stuff. You get the data link, which defines the format of the data over the network. The physical layer, which transmits raw bit stream over the physical medium. Okay. So the application layer, we'll go in depth now. It's the top layer of the OSI model responsible for providing network services directly to end users and applications. At this layer, we have different protocols like the simple mail transfer protocol. We've got the web browsing protocol, which is the HTTPS protocol, which is hypertext transfer protocol. You've got the file transfer protocol, and you've got stacks more on this layer, application layer. Okay. So it manages the user interface and handles high-level data formatting. I just want to make sure this video is still going. Alright, continue. Okay, so this level manages the user interface and handles high-level data formatting, ensuring data can be understood by applications on different systems. Now, this layer plays a crucial role in enabling user-friendly and application-specific network services. Okay, so that's like emailing, that's like web browsing, all that different stuff. It's transferring files over of whatever. Okay, presentation layer. This is the next layer down from application layer. And it's responsible for encryption, decryption for secure communication. It also compresses data to ensure it can be sent and received. This layer is essential. It reduces the amount of data sent over a network, improving efficiency. It also plays a crucial role in data integrity with the encryption and decryption. Okay, now next one, session layer. Session layer controls communication between two devices. It establishes and maintains and terminates connections, ensuring data is exchanged in an orderly and synchronized manner. Handles functions and dialogue control. It also controls the data flow control and synchronization points to enable recovery. And it ensures a connection if it is interrupted, it can be reestablished without data corruption or loss. So it's basically there to like make sure the device can communicate stably without anything happening. And if anything happens, it can recover. Transport layer. Transport layer is the end-to-end communication, ensuring data is reliably sent and accurately delivered between devices. User protocols like TCP, UDP are done in this layer. Manages flow control again, error correction, and retransmission of lost or corrupted data packets. Splits large messages into smaller segments and reassembles them in the destination for efficient transmission. So you know how when you have like packets, like this is where it breaks packets in bits, so you can like in parts, so you can like send them without sending such a large one at a time. Okay. Provides port numbers to identify specific services on device and enable multiple applications to run concurrently on the same device. Now, here's what it looks like. So say you have data like looks like this, created by the application layer, session layer, and presentation layer. The three layers we just went through above. Maybe a lot of it just came from the presentation layer, and it got compressed by this, and this is what it churned out. Data, 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 data. Okay? Example. So the data is broken into smaller chunks by the transport layer. As you can see here, you've got the segment 1, segment 2, segment 3. You got the transport layer header, and the data looks like this. Just data, 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 but it's broken up into 3 sections. Okay, so it's smaller in that sense. So you're not sending one big blob over in one go. So in the PDU, you've got the data. So this is from those different layers. Then you get the transport header with the information on there. Network layer, you've got logical addressing and routing between data devices and different networks. So this one basically assigns the IP address and destination IP address. Uses the Internet Protocol to do that and to identify. Determines the best path to travel from source to destination using routing algorithms. We'll go over that in the later videos. Handles packet forwarding and delivery across multiple networks, overcoming geographical and topology differences. Ensuring data integrity, fragmentation, and reassembly as it travels through different network segments. Okay? So we have the same thing from transport, but we've just added a network header now with the additional information about destination, source, how to get there. You know, we got the routing information, how can we make it more efficient, stuff like that. Data link layer. This layer is subdivided into 2 layers. It is the logical link layer and also does the MAC addressing. All right, so it uses MAC addressing to uniquely identify devices on a local network. So basically when you have a network, information will go to that network, but then it needs to know what device on that network does this information need to be sent to, and that is done via the MAC address. So the MAC address is the one which will pinpoint which device the information needs to go to, because the network will send to the network of that, but the MAC address is which exact device. Manages framing, creating frames that encapsulate data for transmission and enabling error correction. Provides mechanisms for detecting and recovering from errors in physical transmission medium. Common technologies at this layer include Ethernet and Wi-Fi. Okay. As you can see here, we've got the frame. So right here to right here, which encapsulates that data in a sort of frame-like manner. That's why it is called a frame. Physical layer. So this layer operates in ones and zeros. This is the more electrical layer, I guess you could say. So it deals with the hardware, cables, connectors, signaling methods, including voltage, cables, data rates, etc. Transmits raw binary into over a physical medium. Examples of technology at this layer include Ethernet cables, fiber optics, and wireless radio connection, which is like Wi-Fi. Okay, so I hope this video was helpful. This is just a basic introductory into the networking terms, protocols, and stuff like that. We'll go in much more depth. The next series is network media, Ethernet, and Wi-Fi. I hope you guys stayed tuned and enjoyed the video. But it will get exciting because we'll be going into subnet mask, IP addressing, IPv4. How do you calculate how many devices can be on this network? How do you route? How do you build a topology? How do you do all these things? I'm going to cover all of them in this video, and so you guys can follow along. Anyway, I hope you guys enjoyed this video. Peace out. Have a good one. And Isaac's Dev Corner. Subscribe. Give it a check. Catch you guys later.